All right, so we're going to look at permutations with restrictions. By restrictions, I mean rules within those permutations and arrangements. And we're also going to look at permutations with identical objects. So let's start off with this question here. So we have 3 girls and 4 boys to be arranged in a row for a photograph. In how many ways can this be done if there's no restrictions? So pretty much we have 7 people that we are trying to arrange for this photograph. So we could just write 7 factorial. So let's go to our calculator and type that in. 7, and then again, to get to that factorial symbol, we'll type math, scroll over to probability, and then press enter, and we get 5,040. Okay, so now it says the photographer decides that he could take a better photograph if no 2 people of the same gender can sit together. Determine the number of arrangements that he could make. So in this case, I know that in order for no gender to sit beside each other, I'd have to have boy, girl, boy, girl, boy, girl, boy. Right? The boys would have to go first in order for you to be able to alternate them. So out of the 4 boys, I'm arranging 4, and then I'm arranging 3, and then 2, and then 1. Out of the 3 girls, I'm arranging 3, and then 2, and then 1. So I'm just going to go ahead and type this in my calculator. So I have 4 times 3, 4 times 3, times 3, times 2, times 2, times 1, times 1. And I end up with an answer of 144. Okay, actually this question would be a whole lot harder if you had 4 boys and 4 girls, like if you had an even amount, because then you wouldn't know who would go first. So you'd actually have to find all the options where the boys would go first. You would draw your 8 spaces. And then write that all out. And then you would do the exact same thing, but you would write the options where the girls go first. And then you would need to write that all out. And then after you found those 2 scenarios, you would add them together to get the total. All right, so we're actually going to skip this example on the left, just for time's sake, and we're going to look at the one on the right. So Andrew was asked to determine the number of arrangements of the letters of the word brains in which the vowels are together. So this is a new one. So the vowels in brains would be AI. So they have to be together. So what ends up happening is we count them as one item. So we're arranging AI as one item, and then we're also arranging B, R, N, S. So when you count the number of items you're arranging, and remember you're counting the AI as one item, we would count 1, 2, 3, 4, 5. So we have 5 items that we're arranging. However, we're not done yet. So we also need to take into account all the ways you can arrange AI. So we're going to times this by 2 factorial, because we could have AI or IA. I like for you to put the factorial symbol here because a lot of kids will make mistakes when you get to questions where you have more than 2 items that are together, such as 3 items. Okay, so now we're going to type this in our calculator. So we will type 5 factorial times 2 factorial. Okay, and if I type that in my calculator, I get 240 as my answer. Okay, find the number of permutations of the letters in the word kitchen. The letters K, C, and N must be together in that order, K, C, N. So they still count as one item, and the other letters would also count as individual items. So I have I, T, H, and E. So altogether I should have 1, 2, 3, 4, 5, 6, 7 letters I wrote. Okay, so the items, when I'm counting the items, I have 1 item, 2, 3, 4, 5 items. So I'm just going to write 5 factorial. This question is unlike the last because we know that these letters K, C, N must be in that order. So there is no other way to arrange them. So in our calculator, we would just type in that 5 factorial. All right, and we get 120 as our answer. So the next question says the letters K, C, and N must be together, but not necessarily in that order. So I can write this all out, but really I'm going to have the exact same question. I'm going to have 5 items that I'm organizing here, or arranging, okay? But because K, C, and N can be in any order, then I'm actually going to times this by 3 factorial. This 3 factorial represents all the ways you can arrange K, C, and N. So now I'm going to type this in my calculator. 5 factorial times 3 factorial. Okay, and I should end up with 720 as my answer. 720, yay. All right, we're going to look at some identical object questions now. Tom stacks 7 dinner plates. 3 are white and identical, so we're going to highlight that, identical. While the remaining 4 plates are red, green, yellow, and blue. How many different ways can you arrange this? So when you have questions with identical objects, you end up taking an extra little step here because obviously if objects are identical, that will affect your answer. So we're going to start by figuring out how many items you're arranging, just like you normally would. So there's 7 dinner plates, which means I'm arranging 7 items. Now I'm going to divide by all the identical objects. So in this case, I have 3 white identical plates. So I'm going to divide by 3 factorial. And now I'll type this in my calculator. So I'm going to type 7 factorial divided by 3 factorial. Okay, so I end up with 840 as my answer. So 8, oh dear, that moved around. Let me grab that. 840, yay. All right, so you'll see similar questions with letters. So whenever you're given a question where you're asked to rearrange letters, always look at the word and ask yourself, are there any identical letters? In Vancouver, we have 2 V's. It looks like those are the only identical letters. Now we will count all the letters to figure out the total amount of items we're arranging. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we divide by our identical objects. So we're going to take 9 factorial and divide by 2 factorial. And I end up with 181,440. Okay, mathematical, we have 2 M's, 1, 2, 3 A's, 2 T's. All right, and that looks like I got all of the identical objects there. So we're going to count the total in mathematical. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we're going to divide by identical objects. So when we type this one in our calculator, we need to make sure that we put the denominator in brackets or we will end up with the incorrect answer. So we're going to type 12 factorial divided by bracket, what was it, 3, 2, and 2? Yeah. 3 factorial and times 2 factorial. Okay, and then I end up with a pretty big answer there. Oh, I'm missing a 2 though. Oh dear, I'm going to have to rewrite that. Still going to end up with a pretty big answer, but not quite as big. Okay, let's keep moving with these examples here. So you could also have identical objects with pathways. So it asks you find the number of routes from A to B. So no matter which direction you go, if you're always going closer from A to B, you're going to end up going right 3 times, and you'll end up going down 2 times. So altogether, you'll be taking 5 directions, no matter what route you take. You have 3 identical rights, so 3 identical objects here and 2 here. So again, you can type this in your calculator just like this. Make sure you put brackets around the denominator. So when I type it in, I will type 5 factorial divided by 3 factorial times 2 factorial. And my answer is 10. Okay, in our second option here, second question here, we have 2 pathways, but they're joined together. So we're going to figure out all the pathways from A to this little section here. So you would go right 3 times and down 1, 2, 3, 4 times. So altogether we have 7 directions, and we're going 3 right and 4 down. Times here we're going right 2 times and down 2 times. So we have 4 directions, and we're going 2 right and 2 down. So that's how you would type that in your calculator. So let's type that in really quick. So I'd have bracket 7 factorial divided by bracket 4 factorial times 3 factorial. Okay, and then what was our other one? I forgot typing this in. And then 4 over 2 times 2 factorial times 4 factorial divided by 2 factorial times 2 factorial. Okay, and our answer is 210 when we type it in our calculator. Great. All right, so this last question we're going to look at, this is actually a really hard question. So if you want an extra challenge, you could press pause and see if you can figure it out, and then press the play button and see if you got it correct. So at a car dealership, the manager wants to line up 10 cars of the same model in the parking lot. There are 3 red cars, so 3 red. Ooh, actually, let's draw the colors. So I have 3 red cars, 2 blue cars, and 5 green cars. Great. Okay, so in this question, I want to figure out if all 10 cars are lined up in a row facing forward, determine the number of possible car arrangements if the blue cars cannot be together. So we've done lots of examples where they can be together, but not where they can't. So your best bet is to start by just finding all the possible arrangements. So in total, we have 1, 2, 3, 4, 5, 6, 10 cars, right? So this is, I'm going to write out my total arrangements. So I have 10 cars, 3 of those are red, 2 of those are blue, and 5 of those are green. So I'm going to go ahead and type that in my calculator. So I have 10 factorial divided by 5 factorial times 3 factorial times 2 factorial. Okay, and if we type that in, we get 2,520. So that represents all the car arrangements. So now let's figure out where the blue cars are together. So blue together, yay. So if the blue cars were together, so they counted as one item, that would mean if you're counting your items out, you'd have 1, 2, 3, 4, because remember they count as one item, 5, 6, 7, 8, 9. So now you have 9 that you're arranging. I'm actually going to write this down here. So blue together. So now I have 9 items that I'm arranging. I still have 3 red and 5 green, but remember, because those 2 blue items are together, they're one item, right? So It's not an identical object this time because they're together. They count as one item. So now I'm going to type this in my calculator. 9 factorial divided by 5 factorial times 3 factorial. And we end up with 504. So remember, that 504 represents all the times they are together. So now if I wanted to figure out the questions where they're not together, I would just take 2,520 and subtract 504. And if we do that, that'll give us our final answer. So 2,520 minus, what was that, 504? Yeah, I think it was 504, wasn't it? Yeah, 504. Okay. And that's our final answer, 2016. So that is a tricky question. All right, here's some more questions that you can practice.